Good afternoon or good morning, wherever you are, and welcome to the Heroes QEM webinar series. My name is Christine Wood, and I serve as the Assistant Program Director for the Heroes Fellows Program at QEM. For more than 30 years, QEM has been a national catalyst for STEM education transformation and research capacity building. Currently, the QEM network serves nearly 900 colleges and universities and reaches more than 8,000 individuals nationwide. This webinar is part of the HEROES initiative. The HEROES program brings together researchers with experience in the federal government to lend their expertise and support to the STEM research and education communities. Our fellows are here to provide tools and tips for navigating the funding landscape, developing STEM programs and partnerships, and improving talent retention in in-demand fields. We hope this series promotes engagement with our HEROES fellows and provides valuable resources to our participants. During the webinar, we invite you to use the Q&A tool to ask questions, and we'll address those at the end of the presentation. And the webinar recordings and slides will be available in the QEM Resource Hub. By attending this webinar, you will be added to the QEM network and granted access to the Resource Hub. And I am so happy to introduce our presenters today. Dr. Frances Carter Johnson is an innovative problem solver with professional experience spanning commercial, academic, government, and nonprofit sectors, as well as multidisciplinary content, data management, and analytic expertise. Her technical areas of expertise include data science, AI and data, evaluation, public policy, physics, and engineering. And James Smith III is a retiree from the U.S. Department of Defense. In his 20-year career at DoD, he served as a site engineer, software engineer, systems engineer, project director, and an engineering and physical sciences researcher at the North Carolina State University Laboratory for Analytic Sciences. In these roles, he developed and refined expertise in artificial intelligence and machine learning programming, software engineering, and 3D graphics. He also advanced mission-critical research and partnered with students and faculty from minority-serving institutions in support of research goals. And so without further ado, I'd like to turn the floor over to our presenters today.
All right, thank you, Christine. Today we're going to talk about intelligence as far as edge processing, AI, ML on the edge. And the whole goal of this is to just give you guys an understanding of what we're looking for, what we were looking for in the intelligence community. My background comes from when I was working with the Defense Intelligence Agency for about 2 years. And then I worked for NSA for another 18 years. And so these are some of the things, some of the areas we research as far as edge processing concerning AI ML. So without further ado, I'm gonna hand it over to Francis and we can go on to the next slide.
So we'll start to get you all engaged. It's lunchtime, so we want to make sure everyone is here and just want to understand your understanding of what edge processing or edge computing might be. Before we dive into the technical, we want you to have an opportunity to process this concept and tell us what you already know or what you think about it. Christine, if you could share the polls, the opening polls, we'd appreciate it. And just a little housekeeping, we do have other, you can give additional input than the responses that are provided for each question. We ask that you please just put the question number one and then your additional answer if you have an additional answer to these questions that's not listed or response option not given. You can put that in the chat, the webinar chat.
And we'll give participants a few more seconds to respond to the poll.
Thank you. Thank you for your responses. So it seems like most people are familiar. I've heard of edge processing being used in technologies by the general public, but not a lot of familiarity with edge processing. Very little of edge processing being taught in university level courses as represented by people here or in research yet. But we are very familiar with autonomous vehicles and the need for edge processing with autonomous vehicles. This is perfect. Any other? We don't have the additional any additional responses in the chat that I can see yet. But we had about three of you that said there were some other uses of AI edge processing that you're familiar with. We look forward to hearing what those are. Are they in the Q&A or in the chat? I don't see the Q&A. I don't know if anybody else does.
No.
But
So far, no responses in the Q&A or the chat.
okay, that's okay. We'll move forward. So let's talk a little bit about what edge processing is. Edge processing is almost just what you hear. It is processing the data closer to where the data is generated, or that is referred to as the edge. You might also hear other terms like fog computing, distributed computing, edge AI as other terms similar to edge processing. But when we think about a computer network for any organization, we often hear the cloud layer. We know that that's where the servers are, or that's where the data is stored. That's where many organizations have moved to storage of our data at the cloud, at the cloud later level and processing. And we're very familiar with the devices that we use, our laptops, cameras, or devices like that. Those are that's your device layer. But we often don't talk about the edge layer where there might be edge nodes that can process data. So that's what we mean by edge processing. You're not analyzing the data in the cloud, you're analyzing that data in an edge node or in a device that is closer to the device that you're using. So near the edge of the network. That is what the term edge is referring to when we talk about edge processing. So you're not processing as much in the cloud. Conducting edge processing requires an understanding of the IT infrastructure of one's organization. And this is kind of a commercial for our next webinar. We'll talk about it a little bit more at the end. Our next webinar will be Innovative Data Analytic Infrastructure Models for Teaching, Learning, and Research. And why do we say that? Your organization needs to have this edge layer in order to do edge processing. So as we might think about this for research, that might be a question that faculty members may have. You might have to interact with your IT to understand, is edge processing even possible at your institution in particular? And why is edge processing important? James will get into this a lot more when he gives the examples from the intelligence community. But even as we think about in the healthcare community and autonomous processing, autonomous vehicles, you want speed. You do not want your self-driving car does not need to send information to the cloud before it stops the car, right? That information, that processing needs to happen immediately. And we've all read about or experienced the issues with self-driving cars. So we know why that data needs to be processed within the device, within those sensors that are on the car. The sensors need to pick up the information and they need to tell the car to stop immediately. We don't have time. We don't have time to send that information to the cloud. That processing needs to happen immediately. So you need fast processing, and edge processing allows that. Bandwidth efficiency, you do not want to have to send all of your data to the cloud. When you do, you have really high networking costs and data processing costs. So edge processing improves bandwidth efficiency and reliability. It keeps systems working even when you don't have internet. And if you are using some of these edge devices in other situations and you are able to sync your device, right? When you can see yourself syncing a device when you're not on the internet or processing data, then that's an example of you want to be able to do that. And edge processing allows that. And then privacy and security, because edge processing is used in healthcare data and financial data, then you can keep that data secure by processing it without ever having to leave those devices. what are the needs and issues associated with doing artificial intelligence and machine learning on the edge? We have to think about your hardware limits. You might be managing thousands of devices. You have to think about whether the data will be exposed and the security of the data. You also have to think about sometimes you're not able to sync. So you might have some inconsistencies or consistency gaps, or you might have some stale or failed deployments. So lots of needs and issues with AI and ML on the edge, even your upfront costs. So we talked about whether your university or your organization is able to process data on the edge. What's the cost associated with that? Is that a cost that one lab can consume, or is that a cost that needs to happen at the organizational or the university level? The the beauty of edge processing and what we'll really get into today is all types of data can be processed using edge processing. So sound data, text data, video data, and images. And yes, we were going to take questions. We were going to try to take questions per slide. We do see some questions that have popped up in the chat that we can take a stab at before we move to the next slide.
I
Department
would
of War.
say I see Carrie questions. It says, so this sounds like back when we were using thin client machines. I would say, I don't know what organization you come from, but when we use thin clients, it's basically a virtual machine on top of a computer to where they can have access to everything on your computer. With the edge processing, we're saying use that actual physical device itself. You're not putting, in our case, a virtual machine on a thin client in order to make it a thin client. So somewhat similar, maybe, but the thin client was basically allow you to have more resources as far as computer hardware and without having to buy all the different licenses in order to have that hardware stood up. And so you have a virtual machine running and then everything is just virtualized and pushed to your machine. Whereas the edge processing, you using the actual physical device resources to do all your processing.
But this concept of distributed computing has been around for over 30 years. There have been different um, versions and iterations of this. So it might seem similar to something you've used before. My understanding is that 5G and Edge AI have made real-time processing directly on devices critical, right? It's so of course, similar to some things we've done before, but there might be some slight differences. April also had a question or statement we discussed in the Department of War because that was your presentation last week. I think April, you discussed the need to be able to do edge processing near the battlefield. It's also more likely to be a security issue. I think James we'll talk about that a little bit more. Um,
Yep.
okay. Perfect. Thank you, Gregory. Thank you, April. We will move to the next slide. And thank you,
All
Carrie.
right. So, like I say, I worked at NSA for the past 8 years at the Laboratory for Analytic Science. Basically, this was a partnership between NSA and NC State. This is all public information. The link is right there at the bottom where you can go and read everything for yourself to find out more. But it's been around since 2013. And basically, it allows the whole goal of the lab at the whole goal of LAS was to allow collaborators between industry, government, and academia to come into one spot and to solve all these critical issues concerning the intelligence community. And basically, it's a data science shop. And by being a data science shop, AI and ML is used heavily in this here capacity at LAS. And they basically do a call for white papers every year. The call normally starts around end of March, early April. They ask you to basically submit like a 3-page paper to talk about the research you want to do. And through this call, NC State weaves out the ones they want to work with. And then if you're selected, the government folks will come on board and ask you a bunch of questions concerning your white paper to see if this is something they want to partner with you on as far as research. If selected, the research starts in January and it ends in December with a symposium. And they expect everyone to come down for this symposium at the end of the year. Next slide. Okay, so LES has basically three categories: sense making, operational AI ML, and you have human centered AI. That's the category. Human centered AI is basically AI on the edge, along with other things such as audio detection, trying to detect sound in audio and what's going on just strictly versus audio, deep fakes, trying to tell if an image or a video is a fake or not, and what are some of the ways you can try to detect that using AI. Uh, Sense making is strictly basically data. You going through newspapers, articles, PDFs, processing as much as you can in order to analyze all the different texts out there. And then operational AIML. They want to stand this up. How can you stand it up? Like you say, we want to go out into the field. How do you stand this up onto a particular device and without crashing that device, but you still collecting the information you need to collect? So yes, it's three categories, but all three works together doing the research. And like I said before about the previous slide, you come down in December and you get to see all the different research come together and what demos and presentations throughout that was done throughout the year.
Thank you, April, for bringing that name pronunciation to our attention. Christine, will
Yes.
you launch the next poll?
Oh, and let me ask. She asked. Yes, it is a funding. Funding is normally between. It can go anywhere between $100,000 to 250,000 per year. They do year-to-year funding, so you get funding one year doesn't guarantee you're gonna get funded the next year. Every year you have to submit a white paper in order to get funding.
And I will launch the next poll.
Okay, so okay.
So I think there's the question says check all that apply and also single choice. So you could probably only choose one. Um, and feel free to talk about others in the chat if you like. You are right. Thank you guys. Perfect. Thank you. Well, uh-oh, you're muted,
Oh,
James.
sorry. Basically, all of them qualifies as edge devices. Just depends on how you're using it and how you're getting the data to go through it. So, next slide. All right. So, as far as edge devices in the intelligence community, these are the things we were interested in. Of course, mobile phones, laptops, and tablets. We want to be able to move fast and quickly. Drones, we were at NSA, we was looking at drones as far as flocking, like how birds move. Is that signal become interacting between the drones that's communicating between them when you have the different patterns, the pattern movement? Think of it more like a video game. When the drone, if you have like 100 drones take off, what's the pattern? Are they communicating with it? Servers, that's your typical, every agency has servers. You sending everything back to the cloud. I know You send everything back to the cloud to get processed. You need a lot of GPUs. A lot of these devices don't have GPUs. And when I say camera, I put camera only because I'm thinking webcam. Now, yeah, like a webcam, security camera, and being able to interact with the data that's being captured through those cameras. Okay, next slide.
There's a question in the chat about key fobs and hearing aids. And would they be considered an edge device? Can they be considered an edge device?
I would say I don't know, but I would say no because with the key fob, it has to be pre-programmed.
That's what I was
And
thinking.
normally you have to go, I know with the, say like with my car, we need an extra key fob. You got to buy a particular device to program it. Now, can you use an edge device to capture that information being sent to those devices? Yes, because the hearing aid is trying to pick up those signals, and that's what you're trying to listen to is the signal. Key fobs the same way. That's why they tell you, hey, if you have a key fob, wrap it up and fall or something like that to prevent people from getting too close to your house to where they can capture those signals being sent back and forth to where they can open your car door without actually having your key fob. So I wouldn't necessarily consider that an edge device because when I'm saying edge device, I'm talking about data being processed at the edge. To me, the data that it's already been set up is just a communication device at that point, going back and forth with the actual device, such as a car with the key fob, it's already been set up. Whereas the edge processing, your data is coming in and it's being processed in real time, hopefully giving you some results from that. So the data we were interested in, basically everything. We want to text, images, of course, audio. When I say audio, I'm talking about languages, trying to make sense of the sounds, um, dialect, of course, video and video. When we say video, we're talking the actual keyframe. Now, there are other information in a keyframe, but we're more concerned with the actual image from that keyframe, not the metadata of that keyframe. And with the images, we want to make sense of the images. We don't want to have to process every keyframe. And when I say everything, just think if you have a 30-second clip and you're doing it's 30 frames per second. Now you're talking 900 keyframes. You don't want to have to analyze 900 keyframes. You want to be able to pick out which keyframes are relevant. And so this is all the different type of data that we're trying to analyze at the lab that we were trying to analyze at the laboratory for analytic science. So I'm gonna give you some examples of some of the things I worked on. What, like you say, here we have graffiti. Now this is us working with folks overseas. They took pictures, images, and instead of them processing it on their devices, they sending it back to us to analyze. And this is an example. This is all public information of images in Iran, them writing stuff on the wall. We don't necessarily know what this says, so we want to be able to identify the graffiti, understand it, what is it saying, and is this something we need to pay attention to? So that's a topic that they're definitely interested in is different type of graffiti. What is it saying? And it's something we need to pay attention to. And can we do it in real time? Meaning, rather than sending that information back, can I use my smart device, videotape it, and as it's coming in, it's being analyzed in real time. Okay, next. All right, here's an example that we partner with Fayetteville State, working with Dr. Samit Bhattacharya. The ultimate goal was to try to detect Russia and Chinese weapons in real time. Oh, you can start the video. Uh, with that, to try to find this information wasn't readily available. And so what we used in this example was synthetic data. The video on the left is basically synthetic data generated using the Unreal game engine. And these are actual video that we just pulled offline to see if it can actually detect the device. This was us using like a supervised learning process, supervised machine learning. Basically, we labeled the data synthetically and then trained the model to detect these in the real video. But we're trying to get to the point where if you go to the next slide, to where this can be read in and analyzed without having to label the data. And so we were doing a lot of investigation into unsupervised learning. Basically, we want to send in videos and images and see exactly what's going on, give us feedback in the videos, what's taking place, what's relevant, what's irrelevant, based on the analyst's request at that time. The whole goal of all of this is to satisfy, to help the analysts do their job. The analyst is not going to go in and label anything. So you want to look at the video. How can we process this without labeling it? And unsupervised learning was one of the things they are really, really interested in as far as video processing on the edge, meaning they want to, as a videotape recording, they can just feed it in onto that device, run it, and get information back in real time as much as possible. Or if not in real time, if it's not doable, which keyframes are relevant. Instead of having 92 keyframes, can I get what I need out of 5 and process that information? And so if you go to the next slide, this is where we want to track. Oops. This is where we want to track people. We was looking into branding of clothing. When we get a lot of videos and images are coming in daily. I know I had up there 1 terabyte, and I was just trying to keep it low, just not to get in trouble. But it's much, much higher than that, and this is coming in daily. Storage cannot handle all this information coming in. So you got to be able to do a lot of this information up front. And this, the different types of clothing, can you tell us, okay, what does this person have on? Where is it from? And that'll give you a key idea of who that person is with, what country, the type of clothes they like to wear. In this case, I put up American brands just to give you an idea, but if you look at the one in the lower left, that's from Iraq. The center is China, and the brand on the right is Vietnam. And so you want to be able to look at clothing logos, the style, as especially in videos going from frame to frame. Can you say this person is that person? Are you comfortable with saying that this person is that person? And you want to try to make this in real time as much as possible. Next slide. So here's another crowd behavior. You can go ahead and start the slide. What's going on in here is we want to be able to detect the movement patterns between frames. What are they doing? What happened? Like if everything is calm and all of a sudden something happened, can we go back and figure out, okay, where did it come from? This is an example that, some of our military collaborators at Fayetteville State pulled and we used to test. I blocked out a lot of the graphic details, but as you can see, everything's going fine. Explosion goes off. Now we want to be able to go back and see, okay, where did that explosion come from? Can we see the person who put it there? How far back can we go? Also, another good example is what happened in Israel a couple of years back during the concert when they flew in on those helicopters or whatever the flying things. They was all out there dancing and playing and having a good time. And then next thing you know, it was panic. We want to be able to detect the behaviors of the crowd, what's causing that panic. And so this is a good example of everybody, it looked like everybody's going to work, explosion goes off, and now there's panic, people fall and they get up and run. Now we want to be able to go back and analyze that video to see, okay, what exactly led to this? Where did the bomb come from? Look at the injuries, how long it's been there, depending on how much you recorded. So all this we try to do in real time, and those are some of the models we use. These are free and open source. YOLO V8 you can download now. Deep Sort and Poco, I believe you can download from GitHub or Hugging Faces. All this is open source information that we're using to help detect things on the edge. Next slide. All right, this is the area before I left last May. This is one of the big things they was working on. They want to do deep neural network, artificial intelligence using neural networks in real time, using being able to detect basically how much RAM you have, how much storage you have, and using that information to determine how many hidden layers you need and how many neurons you need to have in that hidden layer in order to detect these things. And can we run all of this in real time? Is it feasible? How big does the images need to be, especially when you're dealing with pixels? Uh, One of the common data sets out there is the NIST, I believe it's the NIST data set, where look at the handwriting, it's like 60,000 images in there. That's 28 by 28. And so if you're looking at that, that's 28 by 28. I believe that's what, 800 unique pixels that you send through the hidden layer. How much can that be processed on an edge device? Do we need to reduce that? And not just neural networks. Neural networks is the one that keeps everything together. All these things use its neural network, but convolutional neural networks, we use that a lot for synthetic data generation, processing of images. And we're definitely interested in GANs because if you ever done deep fake, GANs, autoencoder, diffuse models, those were all used to create deep fakes. And the benefit of GANs is we also use it to create synthetic data. You feed it in real data, and you want to train models, your model to where you don't have a lot of data for. You could just create that fake data. And so those are the three things they were looking at in real time processing. Another technology that just came out in, I want to say 2020 or 2021 was Web GPU. The benefit of that is it allows browsers to access the GPU on your devices. So rather than sending the information back to a cloud service provider, if your device, such as a laptop or even some of these modern phones that are coming out and they're having GPUs on there, the browser has access to that GPU now. And so is it possible for us to use web GPU to set up a neural network or GANs and run some of this stuff on? And if not, what are the limitations? So those are the type of information that the agency is looking for as far as running things on the edge. Next slide. So, like I said before, 2027, the call for white papers or abstracts is coming up. The best way to do it is they haven't announced the deadline yet, but if I go back looking at past history, it normally opens up, like I said, end of March, early April. It goes all the way up until June or July is when you have to have your abstracts and white papers in. The best way to do it is subscribe to the mailing list, and they'll send it to you. And like these themes, these are the same themes every year since making operational AI ML human centered. They're very open to the type of research. Like I know one of the projects I worked on was trying to take a 2D screen and create more screen space for the analysts in order to analyze uh, graphics, as you say, maps and everything else, because with a 2D screen, you only got so much space. So that's one of the projects that got funded. And so those are the three categories. And from what I understand, those are probably going to be the same categories as before. And so if you go to the next slide, here are all the links to those links where if you want to look at previous abstracts, you can. That's the PDFs. I put the subscribe link in there where you can go and subscribe, and they'll send you the invite to send in your white papers. Of course, all the other information, past symposium, other previous white papers, all that is freely available on the website. If you're interested in applying, I highly recommend go and read some of the things that was funded in the past. Plus, if you are interested and you want me to look it over, I'm willing to look it over. And who knows, I may be able to get some people I used to work with to look it over and say, yeah, this is interesting. But they're very picky on the type of research, and it has to benefit the intelligence community. That's the only thing they're gonna. If they don't see a benefit in your white paper, they're not gonna fund it. Everything has to benefit the intelligence community. Next slide. So with this poll, I believe the we would like to know as far as we're talking about the intelligence community, what would you like to see? You can just drop this in the chat. Oh, got it. There you go. Uh, yeah, NASA. I mean, yeah, they have. I mean, they've been doing that research for a long time, especially with if you look at Voyager, how that's been going. And that was shipped. Oh, I'm sorry. April put out it said that NASA been doing edge computing for decades. I'm just agreeing with April because if you look at I believe that's Voyager 1. That's about at the end of this year, it's going to hit one light day, but it's still communicating back and forth. So, yeah, they are definitely ahead of the game. But a lot of people are coming on board now. It's too much data out there, and you got to be able to process it in real time, and rather than sending everything back to the cloud service provider. I mean, they just want to reduce the footprint. Everything costs money now. So, let's see, could you clarify? Okay, another question. Could you clarify if edge computing is largely software or cloud firmware being used like using a chip? Oh, okay. In our case, I can talk. We use it was software. We were using Python running on I'm trying to make sure I'm gonna say using Python running on a laptop. We started looking at Android devices in particular in order to program a lot of this stuff software. And so that's why when I mentioned the web GPU, everything we did was software based. And we try not to use anything on the chip. The ultimate goal was we wanted to get out of using GPUs if we could. But with the amount of data that's coming in, I mean, it's hard. It's going to be hard to get around without using GPUs. So you try to look for different techniques such as hash tables, distributed processing, different techniques as far as what you can do with software. I know it was a white paper a long time ago where it was called SLIVE. I think it's called Sublinear Deep Learning Engine, where it came up with a way to where they say it's on par with GPUs, but you're strictly using the CPU resources. So, anything that can help as far as without using GPU, I can let you know right now that agency, I'm gonna say was definitely interested in that.
Great conversation, great discussion. We have about 45% of respondents said yes, they anticipate incorporating edge processing or computing into their research. 45% said maybe, and then 9% said no. I don't think we got any reasons yet in the chat why people might not, but we do have a follow-up question. It leads right into kind of the discussion around this topic and to other slides. If you chose yes, if you're a part of that 45%, do you have any idea about possible edge processing uses or questions in your discipline or area of research? And if you do, feel free to put them in the chat or come off mute to discuss them if you'd like to. And you can think about that as we wrap up our last few slides, but definitely wanted to use this as a idea generation time. Several of you are thinking about it a lot and just wanted to provide some time to discuss that. As we James and I have both mentioned throughout, and I think we're going to start advertising this. Christine is on board to have us start advertising our webinars as kind of a series, data analytics and AI series. We've mentioned it throughout. Our next webinar that we plan to do is innovative data analytic infrastructure models for teaching, learning, and research. So we will probably talk about edge computing as an infrastructure model. Just thinking about how your systems need to be set up, and your maybe data governance as well for different organizations for your lab or for the university level. We think that this is another topic that's interesting and necessary to do some of the advanced data analytics that institutions want and need to do. And then our May topic, James talked about it a lot, using synthetic data for intelligence and other research. So we'll get into those topics. We are trying to open up our office hour space as well. So if you're interested in some of these and if you want to actually get some hands-on experience, um, might be opportunity, reach out to us for opportunities to do office hours on these topics to do some of this analysis if you're interested.
And April has her hand raised, so I am going to allow April to come off mute and ask a question or start a conversation.
Thank you for the topic. It's really very interesting, but I always want to clarify just to make sure I understand. So with edge computing, from the perspective of the applications that may be appropriate for intelligence, must it include an AI perspective where your intelligence is constantly learning and being able to react, or could it just be that you've programmed it appropriately and it's not necessarily an AI function where the system is constantly learning? I'm not sure if you understand what I mean, but
Oh, we done both. We done it to where let me say, we programmed the machine learning. We actually wrote the code for it, and we put that on devices and we shipped it out. But the goal at some point is to go from you want to get it started, put it on the device, and hopefully it will learn as it goes. Now, the thing with the edge device and the programming is only going to do so much, and depending on the task at hand, what you're trying to get it to do, it's only going to be good at that one thing. And so our goal was, since we were interested in object detection of various things, we like the Russian weapons, we trained using the Russian weapons and crowd detection. So that was the goal. You can write the code and train the model, but the problem with that is when you want to do an update, you got to go back, and that was one of the complaints we received was, when it was time for an update, they had to ship the device back and we apply the update, and it go from there. And so that was the big push when I left was, can we do this in real time? How much? And if we can do it in real time, what does that look like? And we
Mhm.
want to do it as close to the edge as possible.
Makes complete sense. Thank you.
You're welcome. Uh, it's a question from Jefferson Younger. I think that's his name. I'm located in North Carolina. Uh, oh, there you go, Francis.
Francis, you sent that chat to only the hosts and panelists.
Am
Can
I
you?
doing that over and over again? Okay. Yeah, great. There we go. Did I do that earlier? Okay, good. But James was saying it in person.
Yeah, I'm
James
located
was doing
in
it.
North Carolina. I'm assigned to work in Texas, but like you say, this is if you have a question or you want me to, it doesn't matter. You can reach out to anybody here at QEM and they will forward the information to the right person, or if they may try to answer it themselves. But yeah, if you want to talk more about it, especially if you want to talk more about the white papers, LES white papers, and that whole process, please reach out.
Could we advance to the closing slide so people can see your contact information?
Yes, yes,
Yep.
yes. So when we say reach out, that's our email, our contact information.
Yep.
The webinar feedback form, the Heroes page, and upcoming events as well.
And we have plenty of time for more questions and conversation. If you'd like to come off mute, raise your hand, or feel free to put something in the chat or in the Q&A box.
Yep.
You're welcome. Thank you all.
Yep.
Well, without further questions, we'll conclude this webinar today. Thank you so much to our presenters, and don't forget to check out the QEM events page for upcoming webinars, the Heroes webpage where you can find contact information for our fellows, and the webinar feedback form to share your thoughts about the webinar today. We look forward to seeing you at another webinar, or especially one of these data analytics and AI series webinars coming up. Have a great day. Thank you so much.